Welcome to the training video for the Purdue ModSquad TA3 system. This is a system used to explore datasets and evaluate a predicted fit for this dataset. And we'll show you how to do that. We accomplish that by going through these steps that are illustrated along the top, 1 through 6. And we do the navigation from these buttons down here, next and back. So I'm going to click this next button. It always shows you which step that you're in over here. This is the variable section. Many of the steps have a little bit of instructions, so you can check these out. In this variable section, I also use variables and the word features interchangeably, so just keep that in mind. Where each of these data sets can be considered sort of tabular in design, where there's a number of columns. Each column is a feature, and then the rows are individuals in the data set that have these measured features in them. In this case, it's a baseball data set. The rows of the data set are individual players, and then we have the number of games that they play, the number of bats, the number of runs they scored, the number of triples they hit, for each of the players. We see the type of the variable, integer, real values for like batting average, 0.250 for 250, or categorical. So we're shown the types of variables here. We want to explore them. We just click on that thing here on the left-hand side. If it's a continuous variable like an integer or real, then we get a histogram and a normal quantile plot, also called a QQ plot. The histogram shows, bins together the values that the individuals had for this feature. Triples are hard to hit, so between 0 and 50 players, had 650 triple. Had between 600 players had between 0 and 50 triples. Sorry about that, reading it backwards. The most number of players had the fewest triples, and then as you go, higher in the number of triples between 100 and 150, then 50 players got it. So this is how you read the histogram. Can't believe I said it backwards. Over here on the QQ plot, what we're looking for, this is what I call a summary statistic. It's a quick way to see what the overall shape of this distribution of values that this feature has. If this feature value across the data set is sort of a bell, what I call a bell curve, where it's centered, the most have the center medium value, some have a high, some have a low value, you'll get a straight line in the QQ plot. If I go back here to something like, the at-bats, you get more of a more centered bell curve, and this QQ plot is more of a straight line. So this is just a quick way of seeing what the individual values, how they bend out, and overall, is it a balanced distribution, kind of a centered, a bell curve. That's how to do it. If it's a continuous variable, if it's a categorical variable, then we list the values that the field takes on, like the position, outfielders, catchers, short run. And then here are the number of entries in the data set that have that particular value for the feature. So we have the most outfielders out of our data set. Of the rows of players, there are more outfielders than any other position. That's how we read the individual variables panel. Let's go on. This exploration viz panel lets you look at two different features against each other. Let's look at a second at just strikeouts, and I'll talk to you about why in a second. Okay, and now we can look at the number of strikeouts we get versus the number of seasons that the player played. And so you can see there's a trend, maybe fewer strikeouts, maybe more strikeouts as you played longer. It's hard to know, so let's look at strikeouts. The more games you play, the more strikeouts you have. That makes sense. So this is a way to kind of compare two variables at a time with each other. And up here, you can pick which variable do you want to compare against everything else. At this point, we introduced the concept of a target variable. You'll see the target variable has been highlighted. This is the variable that generally we're asked to predict the value of, or understand how you would generate the values observed in that feature from all the other ones. So if we pick Hall of Fame, then a player, this is the players who didn't get in the Hall of Fame. There's a lot of them. And here's it's a little hard when it's two categorical variables with each other. It's a little hard to to understand. I'll zoom down here to show you. We use a heat map like that when we have two categorical variables. Here's the value of it, where Hall of Fame is here, and then the position that we play along of the player is along here. And remember how we said there was the most outfielders? Well, for people who did not get in the Hall of Fame is 0, there's more outfielders than there are second basemen or third basemen or whatever. That doesn't necessarily tell us that outfielders don't get in the Hall of Fame. It just means there's more of them that didn't. But remember, there's more outfielders in the data set than anything else. So this is a way to read two categorical variables against each other. If we want to do something like this, did people who did not get in the Hall of Fame, what was their average of fielding? Did they, in terms of the number of errors that they made, whatever, was that related to getting in the Hall of Fame? Not too awfully much, because the way you read a box plot, right? This black line is the average value across the whole data set. This is the very biggest value you get. This is the very smallest value that you get. And this is 25% below the average and 25% above the average. So that's how you read a box plot. And so really, kind of almost everybody has a pretty high fielding average, whether you get in the Hall of Fame or not. So let's look for something else. Okay, here a Hall of Fame seems to be related to the slugging percentage. So people who did not get in the Hall of Fame generally had a lower batting average. People who did get in the Hall of Fame had a higher batting average. So this is a plot that tells us something. These variables are related to each other. So if we want to predict Hall of Fame, we could take a look at the slugging percentage and say, hey, when people are on base and I'm at bat, I tend to get a hit. Those kinds of things get you in the Hall of Fame. So this is a way to explore two variables at a time. And the last thing I'll tell you about this is generally we pick the target variable here. But we wanted you to be able to explore this data set on any variables and look for the relationships of any variables between each other, how the number of seasons relate to your on-base percentage. Okay, let's go on. At this point in time, now we take the data set. I'm going to show you what we do, and then I'm going to describe what this panel is about. You click right here, and then it tells you the name of an algorithm that we're going to compare to, and we're sending the data by clicking the train, sending the data down to that algorithm. Our interface is designed to be able to send data sets to an exploration algorithm called a TA2 in this case, and it's going to try to predict the target variable from the other variables that are in the data set. And so we're giving it time, and it doesn't know exactly how to do this perfectly, so it's going to provide several different examples, and it's up to you, the expert, to pick which of its solutions are the best ones. And that's the point of this, is it's going to give us 5 or 10 examples, and then we pick from those that we like. Here we go. So it's finished. It can take a little while depending on the problem, so you may have to be patient there. So here's the results of our T2 model, and each of these potential solutions we call a pipeline because it did a number of operations in a row, kind of like a pipeline of operations. So we did a number of them in a row. Each attempt is given a unique name. That's all this means. And we've tried to rank these solutions. Here we pick the first 5, you can get 10. We try to rank these from what the computer thinks is the best to the lowest score of a fitting score. We're using area under a curve, which is a known statistics measurement. But this might not be the right solution for this problem that you understand. So what we allow the user to do is to pick candidates they may think are interesting, and then go on next in the next step. And here what we do is each of those that we picked, these are those names again, each of those that we picked, it's going to plot us what's called the residual values against the individuals. And so these, I'll talk about this one. The residuals is the error left over between the actual value of that target variable and what the model predicted. And so if the residual is 0, then for all of these players along this 0 line, the algorithm predicted the correct answer. Whether they are in the Hall of Fame or not, it predicted that correctly. But sometimes the algorithm got it wrong. Sometimes it guessed -1, it guessed less than the actual answer. Sometimes it guessed more than the actual answer. So the idea was to try to get the residuals to be 0. And so what you're looking for in terms of what is the best quality model is the largest number of residuals that are 0. That means out of all of the entities in this data set, the majority of them were predicted correctly. So this residual value was plotted against all the other variables in the data set in case that is helpful. And so this gives you an idea to look at, did it predict better when it was home runs? Did it predict better when it was triples? So this is how to evaluate that one. And then each of the pipelines that we selected on the other page, we can just select right here, and then the outputs of that particular platform are what's shown here. So the process here is to look through which each one of these seems to be the best, decide by reviewing the plots which one is the best solution to the problem. They may be very similar, or they may be different. So that all depends on the algorithm that was used to generate this candidate. But it's your job to sort of see this, decide, okay, maybe this is the one I wanted the best. This is the one that looks the best. Go back and check, okay, it's the one that ends in KJL. Then you go back and you find that one you selected. Hey, okay, this is the one I think is the best solution because I understand the problem better, even though it's not rated the highest. And then you decide to export that one. And so once you said, this is selecting, that's the problem that I'm interested in, that's the solution that I think is the best. And actually then we're done. At this point, you can then just go on and go to the quit in the final selection over here, and we're done. So the idea is to compare several pipelines. I'll go back for a second. Compare the results of several pipelines right here, and then you select the one that you liked, and then hit export. And then we're all done. Thank you so much for your time. I hope you enjoy using ModSquad and exploring the intricacies and how variables are related to each other, and then how the models are able to predict them. And remember to export your selected one when you think it's the best. Thank you. Take care.